Hi everyone. Today I wanted to talk a little bit about timers, but specifically in this context today I'm talking about as a VBA developer, as a database developer, how can we create a timer in code to evaluate the speed of execution of different processes so we can evaluate changes that we make. They can be coding changes, they can also be at the database design level. Does adding an index improve processing, or does it actually do the inverse that we expected? Things like that. So I wanted to show a couple different ways that we can build timers, see how they're used, and then I'm going to show you a more advanced example, a concrete real-life example, so you can really understand how a timer can be implemented and used beneficially to identify which approach is the better approach, and hopefully put you guys in a better position to help yourself make such critical decisions and improve your overall performance. And so let's dig in. So for today's demo, I have a sample database, and it's got a very simple table here, different rows as you can see. We have string data, we have date data, we have numeric data, we have yes/no field. So as you can see, it's just a general table with a variety of fields and over 300,000 records. The queries, the form, they're not for today's discussion, so we don't need to even worry about them. What we're really interested in here are modules, because each module has been set up to show you a different technique. So let's start with the first technique, which is the easiest one, which is the DateDiff. And if we look at DateDiff, it's very simple. It's right here. You simply use DateDiff. You specify 3 arguments. The first one being what is the interval. So in our case, we want seconds. And then you put your start and end values, and it will calculate the interval based on those values. I'm going to comment this out for a second. If we just run it normally, what I've done here is I come at the very beginning and I pull the current date time. Then I do something, and then I set the current date time after it. So I'm grabbing the time at the beginning and I'm grabbing the time at the end. And then I'm feeding it to DateDiff to do the calculation as to how many seconds elapsed. So I'm using here as a process, and I'm going to use it in all my examples of just going and getting the current computer's name. So if we run this just as it is, you're going to see here that you get 0 seconds. This happens so fast that DateDiff can't differentiate the number of seconds that it took. The interval is too big. It can't handle it, so we always get 0. So the only way I could illustrate DateDiff functioning was to add this sleep API and slow down the process by adding a pause. And if we do that, then you'll see DateDiff will work. You're going to get a 1 second value, okay? But as you can see, it's not precise. It's not a highly precise calculation of time differences. So yes, it works, but it's not going to give us the visibility we need. Previously, if we look back in the days of Pentiums, 486, 386, we go back, hard drives were slower, processors were slower, so processes took longer. So DateDiff might have worked, might have been enough for our needs. But with today's technology, it just isn't. I'll also just briefly mention, you see sometimes in different platforms and whatnot, people simply do a direct addition or subtraction to a date. I don't recommend it unless you really understand date times properly. This doesn't necessarily give you the results you're looking for. It can be dangerous. I highly recommend you go through the DateDiff approach. Just a side note. The next timer to look at would be the API, the TimeGetTime API. It's very straightforward here. We've got 2 procedures that are involved. The first one, which is start time, and it's the same idea. We're going to call it initially, and it's going to set a module level variable here. It's going to set it to the current value of the TimeGetTime API. Then we're going to do an action. So once again, I'm doing my debug print of the computer name. And then we go and call elapsed time, which is here. In elapsed time is simply going to once again go get the current TimeGetTime and subtract the initial value that we created when we first called the start time. So it becomes this simple of a procedure. Like I say, we call the start, so it makes what is the current TimeGetTime. We do something, and then I'm just going to print out what is the elapsed time. So if we clear this out for a second, so we're working with a blank slate, and we run it, you're going to see 0. And it's, once again, just not fast enough for our needs. So once again, if we have extended processes, this may be an approach that can be useful to us, but it's not something that works reliably in all situations. So just to prove the point, we could do the same that we did previously and add a sleep, a pause of any arbitrary number. And if we run this, you'll see that now it's going to pick up a value for us. But it's entirely because of the pause that we're creating. Otherwise, it's not precise enough once again. So now we move on to our third option. As we've seen, DateDiff using the TimeGetTime, they're just simply not precise enough. So our next option would be to go over to using QueryPerformance counters. And as you can see, we have our declarations, our API declarations at the top. We have a couple module level variables. And then we have two procedures, a sub and a function of interest. The sub we call initially at the start, and it's just going to go get what is the performance counter when we start. And then we're going to do something. As you can see here, we start, we call it, and then we do something, and then we call the process end timer, which is going to now go check what is the counter at that point. It's also going to determine the frequency. And then it does very simple math, the end value minus the start value divided by the frequency, and that gives us, it outputs us our value. So if we run it, as you can see now, we're starting to get really precise values with multiple decimals. So we're going to be able to start differentiating between fast processes. Several people always ask me, well, why do you use this? Why don't you make it into a class module? I personally prefer to work this way. I just find this much easier to work with. I don't have to worry about different things that you do with class modules. But I know a lot of people out there like class modules, so I just wanted to demonstrate that this can easily be transformed into a class module. We have the same declarations, some module level variables. We initialize, when we initialize, we go get the frequency. Then we have our start, where we go get the start counter. And the end, we get our end counter, and then we do the same math. One minus the other divided by frequency to get our result. So with that, then we can easily use it. And I have two examples here of how it can be used. If we use the first one, I'm just using a with the class. So it's a short form, shall we say. You run it, you've got your value. The second one, more explicit, where we declare it, we set it, we use it, then we set it back to nothing, and it works equally well. So as you can see, QueryPerformance, that is the way to go. There's no doubt about it. You can use it either on its own as subs and function, or if you prefer the method of using class, that's fine. It's available to you. And as I briefly showed, in both cases, the declarations are there for both 64 and 32-bit, so you're good to go in any case. So now let's take a moment to look at some concrete examples. How can this actually be used in a way that can be beneficial to us as developers? So I'm going to start off by simply comparing two different approaches to getting, let's say, a record count. This is something we need to do a lot. It's quite common. I just wanted to illustrate here. I've seen this. I've actually taken over projects where someone will go, and if you look here at the query, select star from the table. So they're going to grab the entire table, and then they're going to go over, looping over the entire table, and then apply a criteria. If the gender F. So I want to only look at the female records. So I'm going to see how long does that take to accomplish versus applying a where clause to only get the records with the gender female. Just to show you that, it may not seem like much with today's technology and everything, but all these fractions of seconds add up, and they really do. And in some processes, if it's repetitive, the difference can actually become quite substantial. You can change processes from seconds to minutes or minutes to hours just by such poor coding. And if we run it, give it a couple seconds, you'll see, look at the difference. That's notable. Every time you're calling it, you're almost a second more if you're using this approach versus using a where clause. And this is where the timers can become beneficial. Sometimes we're writing code, we're writing queries, things like that, and we really don't know. And, was it faster? Well, now with 2 lines, you can know if it truly was faster. The other thing I will say when you're testing, trying to quantify time, is do it more than once, okay? One time is not necessarily properly representative of the situation. So you may want to create a loop mechanism and do it 100 times and then find the average values for each approach. And then you have values that you can compare and reliably use for making decisions and things like that. The second thing I wanted to look at here was using the class module this time. So it's the exact same queries. This one's getting all of them and then using an if to do the filter versus this one uses a where clause. So it's the exact same thing, except now we're using the class module in both cases. So just to demonstrate, whether you use the functions, whether you use the class module, they're both equally efficient. They'll both give you the values and you can use the data to evaluate. Next, I wanted to demonstrate a common thing, a common question. I have a page on my website about how do you get record count? How do you do it the most efficient, fastest way? So here I'm demonstrating we're going to get the entire table, we're going to move to the last, and we're going to pull the record count. And we're pulling all the fields. We're doing a select star. And I get the time here. Then here on this one, instead of getting select star, I'm doing select ID. So I'm only pulling the primary key and doing the same thing, getting the record count. Then the third one, instead of doing a select and getting record count, I'm going to use count directly in SQL to count the number of ID rows and return that value to us to see, is doing it directly in the query faster. Then I'm going to evaluate the speed of using a decount star, versus using a decount on the primary key. So now we're going to have 5 different ways of getting a record count from a table. Let's see which one's fastest. Well, you start looking at your numbers here. 015, okay, we've got them better here. 012, 007, 005, 003. So there you have it. On a large table, it would seem that doing a decount on the primary key is the most efficient and fastest way of getting your record count. So now, very easily, we've managed to identify a way of substantially decreasing the speed had we just done a select star. I wanted to look at a concrete example, how we can use this when we're looking at our table design. So once again, I'm looking at applying a where clause to pull just my female records. And if we come and look at gender, currently it's indexed, okay? So if we run this, let's see how long it takes. Now let's remove the index. And run the exact same code and see if the index actually does anything. Is it beneficial? And as you can see, this is one of the reasons we use indexes, is indexes do improve performance when you need to filter on those fields. So obviously you don't want to go applying indexes everywhere because it's going to increase the size of databases and things like that. But when you know you're going to have fields that you filter on, they definitely are beneficial and will help with queries and your VBA code to run optimally. Then I wanted to just briefly look at how we can use this also with a query, evaluating queries. So what I'm doing here is we're going to have a query here, and we're going to go get all the females that are no longer active. I want to update their end date to right now. Okay, so we're just doing an update query. And as you know here, we have our field here, our table. And if you look at genders, it's not indexed. And you look at active, it's not indexed. So let's see how performant our query is. So if we run our query, we get our value. Took 3/4 of a second. Now if we come here and now we add our index, and let's say we add an index here. Now how does the timing go? It dropped. And then you can even go further than that. You can start looking at, well, is one more beneficial than the other? So does this index really help? So you can remove it, so we're only indexed on the gender, but not on the active. And you can then run it and take a look. Ooh, that went up. And like I said, sometimes you need to run it 2 or 3 times to really get a feel for where does it really situate itself. Okay? So as you can see, it's in the 7 range. We're a little bit lower than initial, but we're nowhere near that 0.5 that we had gotten. So you start seeing that, yeah, I think that in reality that active did help. So we'll put it back. But then maybe gender isn't needed. Maybe that one's useless. So then we can rerun it again. And now without gender. Oh, we're still saying that 7, we're nowhere near that 5. So then you realize, okay, my optimal situation, if I'm going to be using this query a lot, is it looks like these both indexing are beneficial in this case. And then you can run it and just confirm that, yes, indeed, both indexes are optimal for this query. So just wanted to illustrate a little bit. You can use the timer in VBA directly. You can use it to evaluate your queries. You can use it to evaluate processes in VBA, ways of working in VBA. You can compare different code. There's different ways you can use to get the computer name, for instance. In a lot of my examples, right, I was using the create W script, but you can use WMI, you can use PowerShell. There's different approaches you can use. You can pull it from the environment variable. So you can do the same thing. You can evaluate each one and see which one is the fastest. So then you're optimizing your user's experience. You're making things as efficient as you possibly can. And it can all now be done, as I said, with 2 simple lines. You call it, and then you calculate your value. And you can debug it or whatever. Just stepping back for 1 second, I talked about, a lot of this you want to repeat. You don't want to just rely on the first value. You want to create loops. And this is where logging to a table can become very useful. You can create a loop that inserts the elapsed time into a table. You do it 100 times, and then you can just run a query on your table to pull out the average value, and then you have your number to compare with very easily. So that pretty much sums it up. I just wanted to cover basically a couple different approaches and then really emphasize using the counter is the way to go. There's no doubt about it. And do a couple demos, both with the class or plain simple functions. and just show how it can be used and how it can be beneficial to you as a developer to evaluate changes. Even in your form, sometimes, you change your record source. Do I want to bind to the entire table, or do I want to first do something that filters, or first make the user select a specific record and only load that record? Well, if you start evaluating all these options, you're going to quickly identify that it's always optimal to, if you're able to, make them first make a pre-selection and only return a pre-selection rather than the entire table and things like that. So you can very quickly identify ways of trimming the fat off of your database, off of functions, off of processes, and try to improve your users' experience. And at the end of the day, they will be very grateful when you're able to improve things. So that sums it up for timers in VBA to identify performance and optimize processes. I hope you've learned something new. I hope this is useful. If you don't mind, leave me some comments. If you know other timers, please feel free to share. I'd love to learn something new. I didn't invent any of this. These are things that I've come across over the years, whether it be in forums or things that I've researched and found online for my own needs, which was the case with the QueryPerformance counters, because previously I was using another technique, but it wasn't precise enough. So that's where I came across that, and I thought I'd share with you today. Thank you for spending the time to watch the video, and if you don't mind, give me a thumbs up, a subscribe. If you're able to promote my channel or this video in any way on your blog and forums, wherever, please feel free to do so. It'd be greatly appreciated. And have a great day. We'll see you in the next video, guys.